Well, welcome everybody. Thanks for coming for and on such a nice day, even though it's a little cooler, but it's supposed to be in the 60s, so, So that is New Orleans, as somebody mentioned already. That is on St. Charles Avenue, and then the side street is Josephine Street. It's right where we stay. We have a timeshare there, and I always love getting pictures of the two streetcars passing. And then the bus is there as a bonus. So anyway, yeah. So all right. So what we'll do today, I love this picture. I found it this morning. We are going to hear all about abstraction, polymorphism, inheritance, class, object, and encapsulation. I think this is a cool picture. And then this is courtesy of Spiceworks. I'm glad their name's in that. So hello. My name is Michael Redden. I am a Java champion, which is a lot's changed over this past year. So you were here last year. My bio was totally different. So I became a Java champion in April of last year. And for InfoQ, I'm the lead Java editor. And I'm also a contract developer advocate and technical writer at Pyara. I see the logo there. And then I got involved in the Jakarta EE Ambassadors, which was previously the Java EE Guardians. That's a whole long story involving Enterprise Edition of Java. And then I'm a committer on these two specifications, Jakarta NoSQL and Jakarta Data. Oh, and by the way, I retired after 33 and a half years from ExxonMobil. But thank you. I got to keep myself extremely busy. So. Which is good. I mean, so everything you see on top is pretty much my full-time job now. So. All right, so the objectives for today is to talk about object-oriented programming. More importantly are the design principles. And then we'll have some live demos. Does that sound like a plan? All right. So object-oriented programming. So you all heard of C++, you all heard of Java. You got Python, of course, but these are just a small list of others that you may or may not have heard. So the Ada has been around a long time. Eiffel, I know somebody that knows it. The Simula, and all these others like it. Theta should be, I've never really heard of. So, but this is just a small list, right? So it's been around a while. So what is object-oriented programming, right? It is a paradigm that focuses on objects and data. So the other, structured programming is languages like C or BASIC or Pascal, Fortran, right? So you do is you focus on an object itself. This is an object, right? So how do we model that in one of the object-oriented programming languages? Well, we'll talk about that, but an object itself has attributes, right? So it's got color attributes, it's got a shape attribute, but it also has behavior. Maybe this isn't the greatest example, but it does have, we may have behaviors. So this is the whole idea behind that. You wouldn't do that in C. You would do it in C++, but not C. Right. All right. So procedure-oriented and object-oriented, see the differences here. All right. So for procedure-oriented, you have top-down or bottom-up design. That whether you go from abstract to more concrete or vice versa. All right. Whereas object-oriented, you identify objects to be modeled, just like I pointed out with that Clorox wipes container. Structured programming. In procedure-oriented languages, if you think about it, when you write an application in C, well, what do? You do the business logic first, right? So, the algorithms and whatever else you might need. But then it's like, all right, well, now we got to worry about how the user interacts with this. What kind of input do we want? What kind of output do we want to share? That kind of thing. And it's an identification of tasks and how something is done. So object-oriented, concentrate on what that object does. And you actually, which is encapsulation, hide how an object performs its task. And then you identify behavior. Good like well, we'll talk about all that. So an abstract data type is something that's user defined, right? We all know built-in types like ints and floats and booleans and that kind of thing. Well, this is you, the developer, right? You can create your own data type. And part of the encapsulation is being able to come up with these functions or methods that are available, but you hide the internal representation. That's important. All right, there's an interface. So these are these functions or methods in the abstract data type that you, the developer, allow. All right, so obviously for input, you have to allow that input from the user, right? But there are certain things that maybe you don't want the user to be able to manipulate. And then the implementation basically is like an underlying data structure and business logic. Now, in the Java world, interface and implementation are used a little differently. And this is where you declare methods, right? So you have the interface keyword and you declare these methods to do something, but they're empty. And then the implementation is, you implement as that, and then you define those methods, but it has to be those methods, that kind of thing. All right, class and object tend to be used interchangeably, but there are notable differences. So in the class, you define the model, you declare attributes, declare behavior, and it's an abstract data type. An object is live, right? It's an instance of the class, as I was always saying. And because it's live, now it has state, now it has behavior, and you can have many unique objects of the same class. So say you have a car class, and then you can subclass it to Buick and GM and all the others. But then you can have, declare the Buick class and call it Buick 1 as a variable. And you can do the same thing for Buick 2, Buick 3, or wherever your variable. So you can create multiple instances of that same class. All right, 4 main attributes. You saw that in the picture at the beginning. Data encapsulation, abstraction, inheritance, and polymorphism. And the lights went out for some reason. That was weird. Yeah. All right. You come late and then you have to pull a joke on me. Welcome. Thank you. That's it. All right. Data encapsulation is a separation of the implementation from the interface. It's a public view of an object, but the implementation is private. So access to data is only allowed through what you, the developer, would like to allow. And data abstraction is a model of an entity. You define a data type by its functionality as opposed to its implementation. And the example I like to use is a manual transmission. All right, unless you're a mechanic, you know how to use a manual transmission, right? The clutch and the shifter. But if, what's the internal working of that manual transmission? All right, so in my former life, I was an auto tech, so I do know that, but you got the way the gears and the way the power flow goes through the gears and all that good stuff. But anyway, so that's an example I like to use. All right, inheritance. And I mentioned before of subclassing from a car to specific cars like Buick and all that. So it's a means of defining a new class as an extension of a previously defined class. And with that, there's car would be considered a base class, and then child classes or would be the ones that are derived from that car. And because it's inheritance, the derived class inherits everything from that base class. But you could add other attributes, for example, in that derived class. And it is a relationship. So baseball is a sport. So sport would obviously be a base class, and baseball would be a derived class or a child class. So, parent-child. All right, polymorphism is from the Greek meaning many forms. So poly, right? Polyethylene, whatever. So, so this is a way to define a same method, like say it's called display, but you, depending on the what you want to put out for in a display of a base class versus a derived class, you can use that same function signature, say void display and takes no parameters, and then you can put the output differently based on that. But we'll see examples of this. All right, so I've been chatting here the last 5 minutes, and you might be sitting there, so what? What's the big deal of this, right? Well, here it is. So the interface can and should, I should point out, remain unchanged if you want to improve the implementation. So I have the greatest linked list that I want to give to everybody. I have documentation that says this is how you add elements, how you delete, how you sort, all that good stuff. So 6 months down the road, I'm like, you know what? I can make this twice as fast if I do X, Y, and Z. Cool. But the intent is now. So what if I change the way you added and deleted and sorted? What does that do to all your client code? Right? You wouldn't be too happy with it. You might be getting nasty emails, right? You know, how could you? And you know, so that you want to avoid that. So you keep all that the same. Keep that interface the same. And because of this, a great consequence of object-oriented programming is modularity. All the methods tend to be shorter. There's a lot of getter and setter methods that basically, will assign a value to the object or just return the current value of an attribute, those kinds of things. And because of that, well, you can either reuse it or more easily to maintain. So. And it's an emphasis on what and not how. All right. You saw this yesterday, so you can't respond. So anybody, I mean, I'm sure everybody else here knows what this is, right? So any questions so far? I found this and I thought, this is great. I got to use this. The great Rodney. Anybody know his real name?
His real name isn't Rodney Dangerfield?
Rodney Dangerfield, yeah. But his real name, I think, was Roy Cohn, C-O-H-N or C-O-H-E-N. I forget. I have to look it up. But so, any questions? Okay, let's move on here. So we got to 11:10, right? So, all right. All right. What you're going to see a lot in C++ and in Java, and I think even in Python, is the use of the word class or class keyword. That will happen. So class is a user-defined abstract data, right? And it's based on the historic, the struct mechanism in the C programming language, because you can, in a struct, you can add members. I don't think you can declare behavior, but you can add members in the struct going back. And then you would have a constructor and a destructor, and then you have data members or attributes, and then member functions. I tend to be in the C++ world. They're called member functions and methods in the Java world. Go figure. In the Java world, there's no destructor. Memory management is done for you. That's good. It's something to point out. Welcome. Yeah. All right. Classes. You can instantiate them dynamically or statically. You can have more than one constructor. I like to use the word, a primary constructor and a default constructor. Default constructor might implement default values of some kind, and then a regular constructor would have those values passed into it. And we'll see, we'll see examples of this. Uh-oh, got a message here. Yeah. Give me 1 second here. Oh, you don't see that little thing there. Okay. Okay, that's fine. So, of course, now it's blocking my view, though. Get rid of that and go away. Oh, we're connected. I think we got disconnected from Zoom for some reason. Sorry. Oh, wait, maybe we're back on. I don't know what's going on here.
Oh, my goodness. I don't know if anybody can hear me out on Zoom there, but oh, it should be all right. It's going to keep going. Yeah, I think it's not going, is it? Nope. I apologize for this. No worries. I think we will call Orlando, unless I can figure this out. I don't know, but then maybe on my end though. Check your internal connection, or if you're using a public Wi-Fi. Hey, Orlando, it's Mike Redlick. Looks like we somehow got disconnected and we can't establish a secure connection to Zoom. So I don't think we're projecting here, of course, but not over Zoom. So, okay, all right. I'm going to keep going then. So, oh, okay. Yes, yeah, but it's asking me to connect again. So maybe it winked out or something. So maybe I can do it again. Let's see. I don't know. Yeah. Okay. Okay. Yeah, no, that's fine. Yeah, yeah. So, okay, great. Thank you. All right, bye. All right. Apparently, this is something that's a little more widespread here. Oh wait, hold on. Let's see if I can do this real quick, and I'll let them know. Oh, let's see. Oh, click here. Accept Android. Oh no, I should have done the other thing. Okay. No, I don't want that. Oh, good. I got to do the Wi-Fi first. Though. Click there. They changed everything this year. Oh. You know, it's interesting, but maybe it was a 24-hour thing because I did this yesterday. I'll check my email. All right. Oh, wait, here. I didn't get it yet. This will wind up in spam. Don't tell me I have no spam unless it all worked out. Hold on. Oh, here it is. Okay. Oh, there it is. There's the number there. 593,922. Oh, there we go. Okay. Now it looks like we're back. Yeah. Where do I want to be here? All right. All right. Good. Oh, we're gonna close all that. Yeah. Okay. All right. So where was I? Let's see. Sorry about that. Okay. So classes. Oh, I did all this work. Yeah. All right. So we got to talk about class scope. There's a scope resolution operator, and this is mainly used in the C++ books. And so if you have a base class of sports and you have a derived class of baseball, then there's, you want to reference the methods, you would actually use the scope resolution operator and say, hey, I want the display method from sports. So you would do, sports : and, display, that kind of thing, right? Abstract classes. This is basically a way to have a combination of defined methods or, partially, and then some that need to be implemented down the road. Can't think of, for instance, at the moment, but maybe that's your design calls for something like that. So in the Java world, you can have at least one abstract method in your class. And in the C++ world, it's called a pure virtual member function. Now, I'm a little removed from C++ and haven't done this in a while. But it has this very strange syntax of virtual keyword, void as the return type. It means nothing, doesn't return anything. The name of the method is draw, and you assign it to 0. It's just the craziest thing. The first time I saw this, like 20 years ago, I was like, what the heck is this? But there's an abstract keyword in the Java world. So, and it's got public access, and there's public, private, and all that. That's I think I get into that in the next talk. Now, so this is a typical hierarchy. So you see the sports up top, and just for simplicity here, we're going to store a team name, the number of wins, the number of losses, and then we're going to calculate that winning percentage. So baseball, football, and basketball, because they inherit everything from the base class, well, they're going to have all this stuff. But notice here, right? In baseball, they'll play 75 innings before somebody wins, right? And in football and basketball, they don't. They'll, so if there's a tie, there's a tie. But you can include that now in football. So this is where you might see the display idea as a polymorphic thing as a method, because when you output the number of wins, number of losses, and in these cases, the number of ties, and then in the baseball, we'll just do that, okay? So that's, and then the calculation, of course, for percentage will be different because now you have that extra factor in there for that calculation. So this is just a typical diagram for that. Now, when you want to create something in the C++ world,
All right, so you all know int is the type, the data type. And then a variable, let's say I, like you would use in a for loop, for example. Well, the same thing in a class is baseball and then the variable Mets. I'll give you one guess who my favorite baseball team is. All right, so within our constructor, we're going to pass in team name, number of wins, and number of losses. Now, this is an older slide, so I don't know, I forget what they were like. Now, if you want to get the number of wins in your application, you would call this get win method. All right, and then just do it that way, the variable name, and then this dot character, okay, and then it returns the value of 97. Now, of course, you have to assume, of course, there's a get lost, there's a get team name, those kinds of things. Statically or dynamically, it's a little bit different in the C++ world because now you have this star operator. This is C++ and C have pointers. So you do the syntax this way. You precede the variable with the star. So now you're creating an object in memory that points to where the data is. Use the new keyword because now you're going to say, I want to create a new instance of the baseball class and then pass everything in. Now the access to those methods or member functions is this arrow that you create with a dash and a greater than symbol. And then you do it the same way. In the Java world, only one way to do it. Very similar to what we just saw in the C++ side, except there are no pointers in Java. So you just do it the same way, except without that asterisk. And then you use the dot notation to get the win, get number of wins. Oh, and then deleting objects. So C++, of course, you have to manage memory. And then, so if you construct your object as an on top, right, whenever that method goes out of scope that calls it, then it gets wiped out. However, if you use, that's static. If you use a dynamic way, then you would have to use this delete keyword, and then you would actually explicitly say, delete that piece of memory for me, please, with sugar on top. And in Java, there is no way to delete. The memory management in Java is handled for you, something known as a garbage collector. And there are so many different garbage collectors out there now, more so the last few years. There's been a lot of effort on different garbage collectors that have higher performance. But you can use this call to system.gc for garbage collector. However, it does not necessarily guarantee that you're going to, that the garbage collector is going to run right away. So, but you can do that if you want. All right, design principles, and I may have to kick it up here a little bit. 11:10, right? All right. So, hey, Orlando. Yeah, I was able to reconnect. You know what happened? I logged into the Wi-Fi yesterday at ITPC, and it was about 24 hours when, so I just had to reconnect. Yeah. Okay, sounds good. Thank you. Sorry. Okay. All right. Sorry about that. So, of course, the first session of the day, we have all these issues, right? All right. So, design principles. It's a set of underlying principles for creating flexible design. So that's first that little phrase there, and then easy to maintain and adaptable to change. Knowing OOP is a good thing. Okay, but I'm going to show you how things can go awry if necessary. Well, not if necessary, if you're not careful. Because so understanding those basics of object-oriented programming isn't enough. So these are some of the design principles written by the Gang of Four, as they call them. Grady Booch was one of them. Can't remember the other three at the moment. I think there was an Eric Gamma, and then two others. This came out in 1994. So So these principles will be used in some of the different design patterns themselves. So encapsulate with values. Program to interfaces and not implementations, and I'll show a good example of that. Favor composition over inheritance. That's going to be an important one. And classes should be open for extension, but closed for modification. This one, I like this. This one's cool. All right, and then strive for loosely coupled designs for between objects that interact. You don't want them tightly coupled, okay? And then a class should have only one reason to change. So you shouldn't have one big mega class for everything. You should actually design your application to have different classes and then have like maybe one responsibility. All right, so encapsulate what varies. All right, you want to identify and encapsulate areas of code that vary. So best way to, all right, so let's go through this example here. We have an order cars class, okay? And then our method called order car returns of type car. So it's not in here, but there is a car class. All right, and then, all right, so then we'll have it composition, we'll have it in there, embedded in there, the car with variable name cars under, CAR, lowercase. So now we have all this if stuff, right? And so if the model being brought in, right? If it equals Charger, let's create a new Dodge class, right? If it equals Corvette, then a new Chevrolet, and so on and so on. And then after all this is done, after we've determined what car we want, then we're going to build the car, test the car, and ship the car. Right? What in this code will vary? And probably a lot. Which one? Yeah, this part right here, right? So this is just 3 cars. How many cars are out there? Yeah.
You got Dodge, got Chevy, got Ford.
Yeah, but this is going to be big.
Yeah.
And then when you have to change things, right? Right, this is going to be a big mess, and it's going to be hard to maintain. So, but this will stay the same. You're still going to build the car, test the car, and ship the car regardless of what it is. So this is the part that encapsulate what varies. And
Don't mind.
yeah,
How is it?
yeah, I thought I hit it up. There we go.
How is it that Chargers like your Mustang?
Oh, each class will have it different, So a Charger class will be different from a what was the other one? A Ford, for example.
Okay.
Yeah.
So
I may have a more complete application to show.
all right.
Right?
There's a parameter for build car pass, says which car you build. Go to the plan. Control C.
No. So you weren't here the first time I showed this. You know who that is? Ah, Rodney Dangerfield. Look up some of his movies. You won't be disappointed. All right, so here's a live demo. So let's go to our favorite IDE, and let's do the factory. Here's the order cards right here. So of course all right. So of course I have to make things a little bit bigger here because my screen resolution changed when I connected. So this is IntelliJ IDEA, one of my favorite IDEs here. All this is up on GitHub, by the way. All right, so let's see. Let's do a simple one here. This is a Buick. All right, again, this is just for demo. This would be more involved right here. So here is the Buick has a string as its Buick, right? It's its name. Extends car. We should do car first. All right. That would make things a little easier to explain. All right, so you notice this is an abstract class, right? And let's see, what part is, oh, I'm lying, it's not an abstract class.
All right, I gotta go back to this. But anyway, what we're storing here is a make, model, and manufacture, all of type string. All right, and then basically build car, test car, and ship car is just gonna say building the car and, you know, all that. Now, here we're gonna be getting the make for each of these, getting the model. All right, and then, yeah, it's right here. These are the getter methods. So, all right, so then Buick, of course, right, is, this is a constructor. And it takes a string, right? And then it assigns the type to it. And then the manufacturer is General Motors. And then Ford's going to be a little different. All right. So this is, I think, to answer your question a few minutes ago about that, right? This is where you define the differences between them. And you have a Ford factory. And then I have a General Motors factory. I think those are the only two I have. And so here is some of that stuff that I showed you in the slide, all right, to create the car. So each of these has just for General Motors. The other Ford has just for Fords. Now, this is very similar. We're encapsulating somewhat. Is it perfect? No. I'm sure there's other ways to do this if I sat down and thought about it. But this gives you an idea that you create this factory so that you separate a lot of that mess. And then, of course, you know, with some of the new things you can do in Java with pattern matching and, you know, and do a switch statement instead of conditionals with an if, you know, I gotta work on that. But yeah, but this is how you can separate that. And then our order cars, and I can run this, so I didn't open up my IDE, I mean my terminal window. Okay. This is under the publications. Why am I not finding it? All right, hold on. There we go, backwards. Okay, so when I run this, I'm going to be using Maven. I have it that way. Oh no, am I using Gradle? Hold on. Ah, I'm using Gradle, that's right. All right. There are popular build tools in the Java space known as Gradle, and one is Maven. And you can see the output here. All right, so you know, have a little header thing I put out, and then fulfilling the order for Pontiac GTO, building the Pontiac GTO, right, and so on. You can see that. So there we go, better. So you can see by using this, you know, things are, you know, right. All right, and then that was one of the other ones. What time we have here? 10:55. I have 20 minutes or 15 minutes. All right, let's go back to the slides for a bit. And again, you can find these on GitHub. Program to interfaces, not implementations, is a way of eliminating not being locked into a specific implementation. And you can declare generic behavior with that. Okay, so let's take a look here. All right, so we have two small classes. Very simple, right? It's a cat and a cat. Anybody who knows yoga knows cats and cats. So yes, this old man has done yoga. Okay, so but yeah, so basically the meow method will return a string meow, and similarly with the cat. All right, so in our little main application, right, we're going to have a main method, right? That's where everything starts in Java and C++. All right, we'll create a new cat, and we'll write out the cat says, then cat.meow. Similarly,
do the same thing with create a new cow, and then was right out to the screen, the cow says whatever the moo method returns, which is obviously moo. And then here's the output. Not a problem, right? Well, you have to rely on empty variables cat and cow. So now you're tied to those. So let's make this more simple. Let's create a new interface known as animal. And we'll have a speak method that, as you see, is not defined. It's just declared. There's no body to this method. Now, as you see in green, you can change the cat class to implement animal. And this is what I was referring to earlier about implementation and interfaces. And we have this speak method now because we're implementing animal. Now we can define the speak method. So it has to be the same, right? It has to be the one that's declared in the animal interface. And the same thing here. Now I kept these here because they're historic, and then you can get rid of this if you want, right? Again with the lights. All right, so now we've changed our main application to say animal cat equals new cat instead of cat or cow is now animal cow, and whatever other animal you want to define. All right? Yes. So now you're creating one method, you're using one method on there, but it's programming to the interface and not the actual concrete class. Yes.
So the interface for the eyes.
Yes.
It would be like body, right?
No, animal is the more generic, right? So just like a car, you see if you had a car interface, right? A Buick class can implement car.
Right.
So this is the same thing, but you can have a bunny here,
Okay, so I don't know. I'm following the concepts, but
Yeah.
basically, I'm not set up. Right?
It's an interface. It has basically a declared method.
Okay,
Yeah, and then notice the interface keyword. Yeah, that's and instead of class, we had class cat
right. And
instead of interface.
and the people then whatever sound they
Mhm.
make.
Oh, in the and then when we change it, we have to implement. So a class, a concrete class, can implement an interface. And then because the speak method has been declared an animal, now you can define it because now it has a body. And this is the body right here, right? And same thing up there, So now, like I said, you don't need these anymore, but I left them there just for, just to show the difference. And then now you can change it. So you're still using the variable names, but it's tied to the animal and not to the actual concrete class. That's the difference. And you're using the same method name too. That's the other thing. So now you don't have to worry about different rabbit. I don't know what kind of sound rabbits make, but so but yeah, so that's the difference. All right, favorite composition over inheritance, and I probably have not much time there. I can 11 o'clock. I got 10 minutes. All right. I defined is-a before, right? Baseball is a sport. Well, has-a can be better than is-a, and when you get into trouble when you have an excessive use of subclass. And here's an example. And I'm going to skip some of this just so I can get some of this in. And I apologize again for the technical difficulties. So here's a beverage interface. I think it's italicized. And we have house blend, dark roast, decaf, and espresso. Yeah, easy enough, right? Very simple. However, well, in this coffee shop application, well, house blend, we want a house blend with mocha, a house blend with caramel, a house blend with steamed milk. Well, you want the same for the others, right? Now, all of a sudden, look at this mess that's being created. And then I think I have it gets even worse. Oh, okay.
So yeah, so you can see where this gets to be messy. So this is the decorator design pattern. So you have the beverage, you have the original 4 here, but now you have this decorator that contains all these things. So now we've separated everything that's more easy to read and more easy to understand. And it's really cool how it uses this, right? So let's go back to I have this coffee shop, or it's which one is it now? Decorator, here it is, yeah. Okay. All right, so we'll start with an employee. I did an employee application instead of the coffee. Actually, that example was from a great book, which I'll show you later, called Head First Design Patterns. So I didn't want to necessarily, use their example. So anyway, so here's a regular class. We automatically assign employee to the title. And then we have a get title, and your set title, all your getters and setters. And here is a get responsibility method. And you notice it's abstract. There's nothing there. That's because we're going to define that later. We have our decorator that basically extends. So this is how you do inheritance. You use the extends keyword, all right, instead of implements. All right, and then we're gonna get the title. Now you notice that's also declared and it's abstract. Okay, we have a principal investigator. So this was all from my time at Exxon, right? We had all these roles. So we had a default constructor, principal investigator, and set name to be named. All right, and then you can pass in a constructor with a name. And then get responsibility is analyze laboratory data. And then the research technician, very similar, acquires laboratory data. What's it do? Here we go. It's not letting me. So acquires laboratory data. All right. And the same thing. So now one of the roles would be a safety captain. All right. So now you notice what we have here. We have a HAZA. We have this employee embedded in, right? And then what we do is when we create the safety captain, we pass in an employee. Now, that employee can be a principal investigator, it can be a research technician, because they extend from that. So that's why you can use the generic, even if it's a base class, because research technician is an employee, right? So you can, and then assign it to it. So it has it in there already. Now you can say, all right, get title. And then because it's a safety captain, you can say, all right, employee get title, and then get the name, and then add in safety captain. And you can do the same thing and get responsibility. You can automatically dynamically change that to get responsibility and performs quarterly safety inspections, right? So it'll put that out for you. And the same thing for all the other, I have computer science officer, and it has the necessary verbiage for that. So we can, okay, Gradle. All right. Oh, I did observer. What do I want? Decorator. There we go. So move this out of the way. Actually, I'm doing the next session too. So if we go a couple minutes over, if nobody minds. So you can see how we can use the decorator pattern to make these changes. So I was a research tech, right? At one time I was a security officer and a blood drive canvasser and that kind of thing. So I said responsibility include acquire laboratory data and handle computer security issues and canvas employees, that kind of thing. So you can see how these dynamically change. This is this open to change but closed for modification. We didn't change any source code to have this dynamically put that out there. So that was the beauty of all that, right? Yeah, let's let's wrap it up here. These slides are available too, for you, so on my website. I'll show you where that is, yeah. And then the source code is on GitHub. So yeah, let's, only thing I hate about Zoom is everything's in the way. All right, publishers subscribe. Yeah, I'm gonna, let's see, live demos. A class should have only one reason to change, right? All right, so let's wrap up some of the local Java groups. As I mentioned earlier, I'm a director of the Garden State Java user group. We have our meetings in Madison, New Jersey. Anybody from near Madison? No. We do have an online option. So, we rebranded in 2020, but I was the ACGNJ Java user group since 2001. So we've been around a long time. So, and then the New York Java SIG, they've been around since 1996. So they've been so, and I know Frank, Frank Greco, he's one of the leaders. He's the one who started it. The Philly group, we've had folks from there talk by us. I've talked over there. There are a great bunch of folks there too. There is the Capital District Java Developer Network. It's currently restructuring, but I wanted to give them a mention. One of the guys who ran it moved out west and came back and wants to restart things. So we were helping him out for that. And then these are the books. I can't say enough about these head first series of books. The original Gang of Four book on design patterns.
O-K-S.
I must have initiated something. There's all kinds of funny stuff going on today. That original book from 1994 is, it's okay. You can probably take it in bed with you and fall asleep real easy. This, however, is so dynamic. It's the way they have the examples, the way they explain everything, pictures, and it's just, you get so much more out of it, I think, right? Not to really disparage the other book, but these head first patterns, there's a whole bunch of them out there. Some resources, Head First Labs is where you get the books. I had the Meteor book here for some reason, but I need to change that. All right, so at the moment, the slides for today, they're updated here, but I got to put them up. They're just minor changes, but then all these are up on GitHub. The Observer one, I noticed for some reason they're not synced the way they should. But the Factory and the Decorator are, they're up there now. So this is me on Twitter and X. I stopped my political rants about a year or two ago, so because it just wasn't really helping me. So, and it's kind of early. Maybe I should have a slide that has coffee cups for morning and then beer at the end of the day. But I want to thank you for being here. I will be delivering the Getting Started with Java in this next session, which starts in, when does it start? 11:20, yes.